Okay. Once again, good evening and welcome to day 2 of our bootcamp conference. You guys already know why we're having this conference. Basically to enlighten you. Most of you already know what you're coming for. Others, maybe they are still confused. Some persons still have like 2 or 3 courses they are eyeing or they are looking out for. They've not decided yet. You just need clarity on what each role or what each course or each program, each part is all about, and so that it will help your decision-making process. So that's the reason we're having this bootcamp conference. So yesterday, we talked about AI engineering, data science, and data analysis. We went further to talk about product design and full stack web development. These were the parts we talked about yesterday. So even if you missed yesterday's session, not to worry. Webinars are always recorded and then we upload it to our website. And once you're on the group chat on any of the groups, we always drop the link for you guys to replay whenever you want to gain more clarity. Okay. So once we're done with today's session by tomorrow, um, the links will be dropped for you for both the first session and also for the second session being today. All of this is going to be or are going to be dropped for you tomorrow. So you don't have to be scared that, hey, I missed out on the one. I can just make decision based on what I'm hearing today. You can go ahead and watch all of that. Okay, so those are the ones we talked about yesterday. Today we are going to focus on cyber security and DevOps engineering, 2 very strong goals that are far too closely related. That's what we are going to focus on today. Now, however, before I hand over the mic to them to lead the way and then bombard you guys with all they have. You guys should know that our registrations for our courses are still on. So once you're done hearing from them, you've gone, you go through the replay, you've made your decision. Our programs are still, our registrations are still on. And then tomorrow is when we're going to officially kickstart. More information will be dropped for you or will be unveiled to you after the speakers are done with their presentation. So please don't hold anything back when it comes to question. Anything you want to ask, okay? Just like what I would say, you can ask the most stupid question you have in mind. Then they are going to respond to that, okay? Just try to get clarity on whatever you want to do so that you know that you didn't make the wrong decision. Okay, so without wasting much of your time, first I'm going to hand over to cybersecurity expert and instructor, which is Mr. Emmanuel. He's going to take the floor, and please do well to give him some thumbs up and then high five as I hand over to him. Mr. Emmanuel, please. Mr. Emmanuel, are you there? Okay, it seems Mr. Emmanuel is not available. Okay, Mr. TJ, are you good to go? Since Emmanuel is, I don't know if it's network or something.
Yes, I can go.
Okay, perfect then. Sorry. So we just make a swap immediately. Mr. TJ is going to, he's a DevOps engineer and instructor. He'll be the one to be taking you guys. Any question you think you have, any clarity you will have, just go ahead and then once it's done, you can go ahead and bombard him before Mr. Emmanuel comes in. Thank you.
All right, good evening, everyone.
Glad to have you here. So, I won't really take much of your time. So I'll be using the curriculum I prepared to take you all on the DevOps journey, everything we cover for DevOps. So let me share my screen to show you the curriculum. I will go through it one by one. Let me know when you can see my screen.
Yes, we can.
All right. So the DevOps bootcamp. So basically, I will explain a bit of what DevOps is. I think that will help us understand the particular role a DevOps engineer play in any organization. So DevOps is coined from two words, development and operations. So that's why you have dev, then ops, then combined together. So DevOps helps to bridge the gap between developers and the operation team. Initially, before, over the decades, they normally work in silos, like they work separately. And because of this, there used to be hindrances, there used to be some rigidness, and developers can finish coding today, and before the operation team will deploy the application or want it to come out online, to take months, sometimes years. So, but as DevOps started coming into being, it helped to bridge that gap, to reduce the time it takes to market or to deployment, as we normally call it. So you can practically write your code now and deploy it in a matter of minutes, and people can start accessing your application. So that is how DevOps came to be. Now, like I said that was on Monday, there are two things that, like example, when you go to jumia.com or any website URL, there are two things that makes that possible. Two is the programming. One is it is the programming language. Could be Python, it could be JavaScript, could be C Sharp or C and all the rest of them. That is one. Two is the server that runs that programming language. Now, you have the front end, back end, and the full stack developers. They are mostly focused on, or they are focused on writing the codes using any of the programming language. So those codes is just a file, right? They are just set of instructions. So on its own, it does nothing. So it is the work of a DevOps engineer to take that code and run it in a server, right? So that server is basically a machine, could be your laptop. Your laptop can serve as a server that has resources such as CPU, such as RAM, such as storage, because people using your application, when they register, when they input data in your website, they need storage for those data to be stored. Even like images, profile pictures and all that needs to be stored somewhere. So that server needs these resources. So basically, the programming languages, which are the codes, are converted by the server into ones and zeros that the machine can understand. The machine can now execute those codes and give you a response based on the requests that you've sent to the server. So that is basically the relationship between the programming languages, which is the code, and a server. So for a DevOps engineer, the full stack guys are responsible for the code, while you is responsible for the server, right? The server management. So based on a product, based on how a product architecture is, that will determine the deployment strategy that you use. And when I mean by deployment strategy, because of this bootcamp, I will take you through the various ways that you can use to deploy an application. So I mentioned 7 months here because of the pace of work, the pace of learning, because I've taught a lot of people, it takes them a bit of time because DevOps is not something you just rush into. It requires a lot of understanding the basic fundamentals and you grow from there and add to it. So, but if you're a fast learner as well, you can finish it up before the 7 months. And also added to the program is the front end. Because if you check the curriculum, if you check module 1, which is version control with Git and GitHub, you check module 2, modern web framework or modern web foundation, which is HTML and CSS, and if you check module 3, this is JavaScript essentials, and you check module 4, this is React, the modern front-end framework. So this is actually the programming language aspect of it, right? DevOps aspect of it starts from the module 5, which is Linux and shell scripting. So the reason I added this into it is, like I said, the developers will be handing over this code to you to deploy. And if you don't understand how the file is, the folder structure, what to look at, you might not really understand how to deploy it because you'll be asking the developers a lot of questions that you're not even supposed to ask. But if you have an understanding of how code base is, you can write some simple functions and the rest of it. Once they hand you over those files, you can know where to take off from there. And what you just be asking is fewer questions, which will also help choose your deployment strategy. So that is why I added this code aspect of it into the curriculum. So you take this and DevOps starts from module 5, which is Linux and shell scripting. But in terms of time, so that we can finish on time, I'm not going to wait till all these ones are being taught because I'm not the one that will take this module 1, 2, 3, 4, and 5. So you will join me, the front end guys, to learn this. So while they are also teaching you this front end, I will start the DevOps part so that we'll be fast enough to finish. So based on that, I've explained module 1 to 4. So let me continue from module 5. But before that, I think there are some things I'm supposed to explain also. I think this will be shared to you as well. Right. So why this program standards? You get to do real projects, not just videos or me explaining. You get to do really hands-on projects that will actually help you. So you also, yes, every module ends with a hands-on project you push to GitHub. Then you also learn how to deploy a modern full-stack application, front-end, back-end. Even I'll go as ahead of even teaching you how to create a database and connect applications to those databases, end-to-end stuff. So we'll also talk about, because all these things, we'll also talk about AWS. AWS is the cloud platform we use. When we get to that place, I'll explain how AWS comes in. But along the line, when I go down, I'll also explain a bit of AWS. Then automation too. So most of these things, when I said you can push your code from your machine to live, to people using it in minutes, automation is what helps. Everything is automated. Once the developer hits git push, everything runs automated. You don't need to do any manual thing because you've set it up. So after the end of this program, you'll be career ready, like very, very much career ready. So who this is for complete beginners. So beginners, that's why I added the front end part. But if you're not a beginner, it's even far better. Like if you're already a front-end or back-end developer and you want to add DevOps or collab skills, this is also for your IT professionals, other IT professionals like sysadmins, support engineers. When you want to switch to DevOps, you can also join. So by the end of, obviously, you will be amazed by what you do by the end of this cohort. So back to the curriculum. So back to module 5. So Linux and share scripting. So I talked about servers, right? So servers, they run on operating system. So the three major ones we have are Linux, we have Windows, and Mac OS, right? But most applications runs on Linux. So Linux is very important. Even the cyber security guys, they use Linux. So we'll be dual effects on Linux. In fact, Linux is like 40% of everything, if almost 40 to 50% of everything you do in your DevOps journey. If you master it, you're good to go. Right. So the next is networking. So we also learn about networking, how everything talks to each other, how, for example, if you click on junior.com, how traffic routes from your browser to wherever junior.com is hosted and back, and how you receive a request, and every other networking model that you need to know. Basically, how you talk to, how every devices and every machine talk to each other on the internet. That will cover the networking. So for AWS now, right? So the concept of AWS and other big cloud providers is, like I said, your machine, your laptop can be a server, right? But codes running on your laptop can only be seen by you, right? If you want this, if you want other people to actually see this code, what that is running, you need to do some extra connections, right? So this extra thing costs, they cost money. You buy servers, you buy a whole lot of hardware and also connect them. So imagine you're a startup or you want to set up a business and you're paying developers to write this code, and you also, in order to run it, you still go and pay huge amounts for servers and everything and hardware. So because of this, um, uh, creating a software product used to be hard. So that's where the big boys came in and comes in, the AWS, the GCP, the Azure. So what they do is they buy these servers in larger quantity, right? So you that needs just small, just maybe one server with small resources, you then meet them and say, okay, I need this server with these resources. I'll pay, okay, they use the economic of scales where you pay the minimum amount. To you, it's very small, but to them, because of the rest of you are paying for it, it's huge profit on their own end. So you can just say, okay, I only have $5 a month to pay, or let me say 5,000 or 10,000 or 15,000 to pay a month. So you can actually meet AWS and they will rent you this server. It's more like renting. So they will rent you the server, then you can now connect to it and deploy your application or run your application. So that's where AWS comes in, GCP, and the name cloud. Cloud is not really that it is in the cloud, it's because the server is somewhere, right? So when we go to AWS deeply, you will learn about regions. So regions are the different places AWS have set up these servers, or a cluster of it is called data centers, where AWS have set up these data centers. So you choose where you want to set yours up based on different factors, which we'll learn during the course of the bootcamp. So next we'll enter Docker. I think Docker helps us to resolve a lot of issues, especially the issue of it works on my machine and it doesn't work on another machine. I think developers will understand this one. So Docker and containers, it helps us to package our products into, you can basically call it container, yes. You package everything inside there so that any machine that you're running it, you run it will run. Any machine where you're taking it to, it will also run. That is Docker. Then infrastructure as code, which we call IAC. So remember I talked about creating server. So you could obviously, when you create an AWS account and you go there and you create servers, you can create servers from AWS. You can do this manually, but it is well, I say one is time consuming. Two, you cannot keep up to, let's say you just go to AWS, you click create this, create this, create this. You cannot actually keep a record of what you've created. And it's not also automated. That is where infrastructure as code comes in. So the infrastructure you create or whatever resources you create in AWS, you can create it with Terraform as files in your local PC, right? So you just write it in as files or as code, as Terraform code. So and you click apply. Once you apply, it will talk to AWS and create those resources for you. One of the importance is one, reusability. So you can reuse that Terraform files elsewhere. Two, also maintains is maintainability as well. Like you can go back and say, okay, I created one server here, I created two server here. You can always remember what you've done. Compared to today, you just go to AWS console, what I mean console their dashboard, and you create 1, 2, 3. Next 2 months or next 3 months, you might not remember what you've created. But Terraform is in the file there. You can always go back and say, okay, this is what I created. Fine. And you just remember. So CI/CD with GitHub Action. So remember how I also talked about how a developer can click git push, and before you know, in a matter of minutes, they can see the application live. So this is where full automation comes in. CI/CD, call it continuous integration and continuous deployment. So this helps. This you set it up in GitHub. So once there's any push that has been done to GitHub, it takes that code, it packages it. If okay, there's any test that you've set out, it will run the test on that code to make sure everything is okay and fine. And it will package it and it will deploy it to AWS for you. Before you know, everything is live. You don't need to touch anything because you've already configured it. Your automation works without you even being available or without you even touching anything. All right, so Kubernetes is the big boy in town. So, sorry, Kubernetes is the big boy in town. So we talked about Docker and container earlier, right? So what Docker does is it packages your code base. Yes, let me call it like that. You can call it code base or you can call it your application. But let me use code base. That's what we might understand. It packages your code base into what we call a container, right? So you just put that container, it stores it somewhere. So what Kubernetes helps to do is, if you're running that container, you can just run once. There's not an issue. You can create 2 of those, even 5 of those. You can manage it. So imagine you are now running 20, 50, hundreds of those containers. It will get very messy. You cannot keep up with managing them. So it's where Kubernetes comes in. It's called an container orchestration tool. Right? It helps orchestrate containers at large scale. This is why big companies, this is the tool they mostly use. This tool was developed by engineers at Google. So Google are the ones that owned Kubernetes before they open sourced it, and every company had now developed their suited for their own use case. So, but Kubernetes actually helps us to, it solves a lot of headache when you are deploying some, let's say, some multi-architecture applications, so applications that are very, very, very complicated, have different microservices around them. So that is Kubernetes. I think the last of this is observability monitoring. So when I was learning DevOps, I used to ask myself, okay, if we are done setting all these things up, everything is automated. So what is not the day-to-day job of a DevOps engineer? So this is where observability comes in. So it's not just deploying your code and is wrong. You need to like monitor it. I think a lot of us uses Nigerian bank apps, right? So You can sometimes, I don't want to mention bad name, but their apps used to be down a lot of times, right? So you get to monitor the application when anything is wrong. You have to be aware so that whenever something is down, you are aware and you resolve it. Um, and you make sure you're always on call. Because the job of a DevOps is you have to always be on call. Like you have to always be around. So when something breaks or something is not working, it's you that will be called on first, and you'll be the one to go and check what it is. And you can only know what happened based on the monitoring tools you've set up. So these tools monitor the application and sends you the logs, sends you the numbers. It could be percentage. You will say, okay, I want to monitor CPU percentage. Once it reaches 80%, notify me. It could notify you via email or via Slack or via any communication channel your company uses. And you know that, oh, CPU usage has reached 80%. Okay, I need to add more CPU. Yeah, or this or another thing might be done, you need to resolve. So it just notifies you um, before something goes down, and also observability. And not just before something goes down, even when something goes down, you can trace. Which just why an email refuse to send, because there are so many applications now, they do user registration. User registration requires email verification and sending some kind of notification via email. So it's simple an email not sending. You have to trace why that email did not send. So it's part of your work too. And also you also collaborate with engineers in figuring this out, but you will do the majority of the setup. So that's where monitoring and observability comes in. So that's basically it. There are lots of career paths along this line. So from junior DevOps, DevOps, which is cloud support. I talked about platform engineering to site reliability engineering and all of that. So yeah, it's the career path is large. So I think that's all. I don't know if questions can come here or if it is later. George.
Okay. Thank you so much, TG. And I believe we've all learned a thing or two from what he said. So maybe we'll just give the next 5 to 7 minutes for questions. So if you have any questions, just raise up your hands. We'll call you up and ask your questions relating to everything he has said or anything that's bothering you. So if you have questions, either you drop it on the comments or you raise your hand so you can be called up. Questions? Okay. I can see that everything he said was clear and we understand everything. So if we can move ahead, just drop an emoji. If we can move ahead, drop an emoji. So I can be sure that we are still together. If you can hear me, drop an emoji so we can move on. If you don't have any questions. Okay, okay, okay. All right, without wasting too much time, I will call on the next speaker, who is Emmanuel, who will be taking us on our cybersecurity classes. He's the tutor for cybersecurity. So, Emmanuel, if you're with us, you can take the floor.
Um, okay, good evening, guys. Good evening, everyone. My name is Emmanuel. Please, if you can hear me, just drop an emoji. Okay, okay. Thank you. So my name is Emmanuel, and I am a security engineer and also a tutor in SmartHub Academy. Let me just share my screen so we can just start up. There's no time. Okay. So I believe you guys can see my screen now. Okay. Okay, let's start. So first of all, what is cybersecurity? I'm sure that most of you must have heard of cybersecurity, but I'll still do a brief recap on what cybersecurity is. So cybersecurity is just the practice of protecting computers, networks, systems, applications, and our data from cyber attacks unauthorized access, or digital threats. So we have daily cyber attacks that keep happening. We have people trying to make unauthorized access. For example, on your bank app, we have those that are trying to make unauthorized access into your bank app. They are trying to break your password, trying to gain access into your social media accounts, maybe your Facebook, your WhatsApp, or your Instagram. And we also have the digital threats. We have the digital threats. So digital threats is just online threats. Digital means online. So online threats like phishing attacks, malware attacks, virus, and different things. So that's where the cybersecurity guys comes in, because we try to protect computers, networks, systems, application, data, and even people from this form of attacks. So let's go to why cybersecurity matters. We've even discussed a lot of it, but let's still discuss more. So why does cybersecurity matters a lot? So organizations depends on technology daily. Like I don't even want to imagine what will happen if the banks stop functioning online. If the banks stop functioning online, or you want to make payments, you want to make school fees payments, and you're not able to make payments. So organizations depends on technology daily, and if they depend on those technology, they need the cybersecurity engineers to secure those technology. So that's why you always find us there, because we have to secure those technology, we have to secure those networks, those companies, and the systems too. So we don't just secure, we also dictate and investigate attacks, because most of the time, even with the security and everything, attacks still happens. So whenever an attack happens, we try to investigate the attack. We investigate what happens and how it happens and who is responsible for it. So we don't just investigate the attack. We also check who is responsible for it, just like the detectives in our force do, in the police do. They don't just check what happens. They also check who is responsible for it. So we'll also do that in cybersecurity too. Then apart from that, we also configure enterprise security tools like the firewalls, the intrusion prevention tools, and different things. We also protect applications and users too. So applications like the banks and other forms of applications, and those making use of the applications. Then we monitor and defend infrastructures. So we monitor infrastructures to check those making use of the infrastructures, both those in the organization and those outside the organization. So we don't just protect the organization from outside attacks. We also protect organizations from inside threats too. because most of the time we have a lot of inside threats that we can't even imagine. So we protect the organization from both inside and outside threats too. Then lastly, you're going to understand ethical hacking and phishing awareness, which I'll talk about the phishing later. So before we move on, let's talk about career opportunities in cybersecurity. So we have SOC analysis, which is the most popular one, or will I say the most popular one, or should I say SOC analysis is where you find a lot of jobs. Is where you find a lot of jobs. So we have SOC analysis. So the work of the job description of SOC analysis is that they monitor security alerts and response to threats. So they just sit down on their system, monitoring security alerts, monitoring things that are coming inside the organization and things that are leaving the organization. So they just monitor for network traffics. So they check network traffics, they check the ports that are coming in, they check everything coming in. So they monitor these things to make sure that everything is in order. And if there is something fishy, they respond to the threats. They check if it's a false alert or a real threat, because most of the time you have a lot of false alerts and you don't want to disrupt the network because of false alerts. So you have to investigate to see if it's a real threat or a false alert. Then if it's a real threat, you respond to the threat. And we have the average salary is between $50,000 to $110,000 yearly. So I think it has the lowest form of salary because you actually don't have much work to do, because it's not like you're sitting down monitoring for security threats and the rest. You have tools, you have security tools that does that for you. So you all need to make sure that the security tools are following the right protocols and you're checking out for false alerts too. So that's just your work. So it's not like you're sitting there 24 hours to monitor. So you're making use of security tools to do things like that. So we have the network security engineer. So the network security engineer, their job is to just secure the networks and infrastructure in general. So their salary structure is between $70,000 to $140,000 yearly. Then we have the incident responders. So these people, they just investigate and contain cyber attacks. So they come in whenever there's a cyber attack. So whenever there's a cyber attack, they investigate, they check what happens. So they check what happens and they try to contain the attack so it will not spread around the organization. So they try to contain the attack. And so they try to contain the attack by making sure the attack does not spread to other parts of the organization. For example, once there's an attack in an organization, after containing that part, the other parts are meant to change their password and implement some security rules. So we also have the security analysts. So these people analyze vulnerabilities and also improve security in general. So these days we have a lot of vulnerabilities around networks and applications. So the work of the security analyst is to analyze those vulnerabilities and also improve security in general. Then we have the application security engineer. So the application security engineer just secure the web application and mobile application in general. So they make sure there's what we call secure coding. So secure coding is just while the developers are writing the code, the application security engineer is making sure that those codes are secured. You're writing those codes securely. You're not writing a code that will end up making the application get breached or get hacked by a malicious hacker. So that's just the work of a security, or the work of application security engineer. So we make sure the web application and the mobile application are well secured. We also do what we call bug hunting. That is, after the application has been developed and deployed, we also perform a black box testing. That's bug hunting. That's where we try to check the functionalities of the application to see where a malicious hacker can breach. So once we find that endpoint where a malicious hacker can breach, we submit it to the developer or to the company, and they fix it. So after fixing, we retest again to make sure it's being fixed properly. So we also have the penetration testers. So penetration testers is similar to application security engineer, but penetration tester in general simulates attacks to find weakness. So it's just like, okay, it's just like catch me if you can. For example, okay, this is our network. Try and see if you can break inside our network. Now, if you can break inside our network, you write a report and give us, you tell us how you broke inside our network. Okay, there's a question. Sorry, sir, do you actually hack complaints purposely? Yes, we do that with permission. So that's even the fun of, I think that's why I found cybersecurity very fun and interesting, because you're being given the organization network and application to actually hack into it with permission. Now, we're ethical hackers. Everything we do them ethically. We get permission from the organization or the owner of the application. So you don't just do things without permission. So you get written permission, not just mouth-to-mouth permission. You get written permission. The organization signed, and you also sign too. Then you start hacking the organization, and if you can hack your way in, once you hack your way in, it's not like you've hacked your way in. Now you're seeing sensitive information, you're going to steal them. You don't have, if you steal them, you get arrested for that. Once you can hack your way in, you write a detailed report on how you did that and submit to the organization. You can even give a hint of how they can secure the network more. You understand? Maybe, for example, they might be running an outdated application. So you tell them that this application you're running is now vulnerable. You have to update the application to the latest. You have to update the application. So you have to update the application. So things like that. So that's how you actually do things like that. Is there any other question? If there's no question, then let's move on. So we also have cybersecurity consultants. So these set of guys gives advice to company on security strategies, security measures. Okay, this is what you should do, this is what you should this is what you should put in place. Okay, you don't need to hire this, you can do this. So they just give security advice to companies on how to go about on building their security structures. So these guys over here get paid a huge amount of money just to give advice. That is $90,000 to $180,000. But I think this is a senior role, so it's not something a beginner can do. Then we have the DevSecOps. That is just like my colleague just presented. He presented DevOps. So we have the DevSecOps. So DevSecOps is just DevOps security engineer. You understand? DevOps security engineer. So you just integrate security into development. That's the job of the DevSecOps, is to integrate security into whatever the DevOps guys are doing. You understand? That is the development process, the operational process, the deployment process. You just make sure there's security in every area of the process, the development process, the operational process, the deployment and everything. So you just help them to do it in a more secured way. So these guys, they get paid huge amount of money, and I think there's a lot of job opportunities in this area too. So we have $100,000 to 190. Then we have the digital forensics analyst. So they investigate cybercrime and find evidence of the crime too. So they find evidence of what happened. So we don't have much time. Let's just quickly go down to the course module. This is what you'll be learning in the class actually. So this is what you'll be learning in the class. So the first thing we are going to learn is we are going to learn cyber security fundamentals. So you learn cyber security fundamentals. So this is the description. You learn the fundamental principle of cybersecurity, common attack threats, malware, security concepts, and other stuffs. So you learn things like the CIA triad, things like basic security principles and concepts, and malware fundamentals, threat actors, motivations, different things. That's what you just learn the fundamentals of cybersecurity in general. So after that, you'll be learning networking. So we'll be learning networking. I think networking it's a very broad stuff that you need networking in cybersecurity. You also need networking in DevOps and other tech fields too, because networking is just how devices communicate to each other. Like how you send message from one end to another end, how you download file from your device. Okay, you download file from another device to your device and other stuff. Even when you want to make payments, you go to another device from your device. So you're communicating from one device to another device. So networking just make you understand what is happening during that process of when you're communicating from one device to another device or multiple devices. So in general, networking is just the communication between two or more devices. You understand? So you'll be learning networking, because if you don't know how devices talk to each other, then how do you want to know how to secure them when you don't even know how they communicate to each other? So that's why we'll be learning networking before we even start learning how to attack and how to do magics and other stuff. Then after learning networking, the next thing we are going to learn is operating system. So we are going to learn Windows and Linux, because Windows operating system it's the operating system that is more in use. So we use more of Windows in companies. So companies make use of Windows mostly. So we should learn how to make use of Windows operating system, because we'll be securing companies' infrastructure. So if we don't know how to use Windows operating system, then how are we going to protect those infrastructures when we don't even know how to use the operating system? Then next, we are going to be learning Linux operating system. So Linux operating system is where we work from. So if you don't know how to use your working tools, then what is the point of learning cybersecurity? And Linux, like my colleague said, it's widely used in a lot of tech field. So you're also going to learn Linux operating system. So then next, we are going to learn how to improve security of organization. So we are going to learn how to improve security of organization using advanced firewall setups, and we are going to make use of PFSec. So I know you guys, most of you won't know what PFSec is, but it's just it's an example of the infrastructure that we are going to be setting up. So make use of PFSec, and we'll learn how to set advanced firewall rules and setups. So this is where we learn how to configure firewall rules, how to set up VPNs, NAT, and traffic filtering and other stuffs. Next, we'll be learning network monitoring and systems. So we'll learn how to monitor systems and network for suspicious activities. That is where I talked about the traffic coming into the network and the ones leaving the network too. So we'll learn detecting intrusion. We'll learn detecting intrusion too. We'll also learn because of time, we'll learn investigating incidents too. So we'll learn how to add in our security. So we'll learn that is what we call secure systems and secure networks. So we'll learn how to secure our systems and network against attacks. So from there, we're also going to learn application security. So we'll learn application security. That's securing the web and mobile application from vulnerabilities. So we'll learn how to secure the web and mobile applications from vulnerabilities. We'll learn how to bug hunt them. So bug just means errors, in case you don't know what bug means. So bug means errors. So we'll learn how to error hunt. That is finding of errors in those applications that the software engineers build. So we'll learn how to find errors from what they develop. So from there, we're also going to be learning social engineering and phishing assessments. So we're learning social engineering and phishing assessments because most of the time, you might not find error in the company's infrastructure. That is the networks, the application, the system, and the infrastructure in general. You might not find any error. Maybe they have spent a lot of money. Some companies even spend millions of dollars just to secure their infrastructures. And let's say everything is up to date. There's no bugs. There's no vulnerability. There's nothing on the system. This is where we default to human stupidity. Because there's a quote that says, humans are very stupid. But not all humans, but humans are very stupid in general. Because we have this sympathy that machines don't have. So computers don't have sympathies. Computers follows rules. So if you tell computer that don't allow this person, this social person to enter, the computer won't allow that person to enter. If you tell a computer that anyone that does not have access card should not enter, no matter who you are, you're not going to enter. That's how computers are. But humans, if you tell humans that don't allow anyone without access card to enter, maybe someone might come pretending to be your friend and you might fall for it and you allow the person enter. Now, you break the rule just because of emotions and you allow the malicious person enter. You never can tell if it's that person that will reach the company's network. Or maybe you send a link to someone and you tell the person that, please, I'm contesting for something. Please, can you just kindly vote for me? And the person just think that, is it not just to vote? Okay. Then the person now use his working system to click on the link. Automatically, you breached that network without even hacking in. You just breach the network with the person's emotion without even hacking into your way. You fish the person, you fished in your way. So that's what we'll be learning here, how to perform phishing and those attacks in this section. So by the end of this course, you should understand cybersecurity concepts. You should also understand secure systems and network. You should understand how to detect and investigate cyber threats. You should also know how to configure enterprise security tools, that is company security tools. You should know how to improve organization securities in general. And this course will also prepare you for entry-level cybersecurity jobs, that is roles. Then in this course, because it's 100% practical. So the course is 100% practical. So at each point, we're always doing something. So it's not more of saying, it's more of doing. So we are doing something and everything. And the little advice I can give you guys is why the course is going on or why the class is going on. You're expected to go back home and practice over and over again because you have short amount of time to learn huge amount of things. So if you don't practice on your own, you will not go far in this field. You will miss out in a lot of things. So it is advisable that you practice over and over and over again. So there will be a lot of labs. There's what we call labs. Now those labs, we need to actually hack into an organization. We need to protect an organization and everything. Now, we cannot go out there and start hacking into a production organization. For example, we can't go out there and start hacking into Access Bank application. If we do things like that, it might disrupt Access Bank's network, and they will not be able to provide services, and it will cause huge amount of loss to their company. So we can't go out there and start attacking people's organization. That's why we have labs. Now, the work of these labs is that they simulate real organizations. Like, it is being set up like a real organization. So we are actually attacking those labs, not the real organization. So we'll be working on a lot of labs and a lot of things. So I also prepare you guys for your, like, I'll prepare you guys in career-wise and other stuffs. So I think that is it. That is it. So lastly, I dropped this stuff. So lastly, cybersecurity is not just about technology. It is not just about technology. It is about protecting people, systems, business, and the future. So we are protecting people, your loved ones, and system. Because I could remember when some hackers hacked into my sister's social media accounts, business Instagram. She has a lot of followers there, more than 50,000 followers, and it is her business account. And I was able to recover it for her, and she was extremely happy about that. So it's not just about technology, it's about protecting people around us. It's about protecting their systems, their business, and also the future too. So so that is it with cybersecurity. So I'll be taking questions. So I'm open to questions. So you can drop the question or raise your hand if you have a question. Okay, so you can keep dropping the questions, so I will attend to everything. So let's start with James. So is there any specific programming language for it? Okay, so now this is it. Programming language is not a must. So it is not a must. It depends. So programming language is not a must. It depends on the area you're going into. For example, we have these job roles. We have SOC, we have network engineer, we have application engineer, we have different job roles. Now you cannot go into all this. That's the beauty of cybersecurity. You have different areas to choose where you want to specialize on. For example, or for instance, someone going for SOC analysis do not need to learn any form of programming language. But someone going into application security engineer need to learn the web language. You understand? You need to know JavaScript. You need to know JavaScript. That is someone going into web application engineer. Someone going into pension testing need to know Python. You understand? Someone going into DeepSecOps needs to understand how DevOps works. Now, how DevOps works. Now, you don't need to know how DevOps works in general. Like, you just need to have an idea. You don't need to go and study DevOps from beginning to the end. You just need to have an idea of how it works. Same thing too with Python. Okay, same thing too with Python. You don't need to understand how to build an application with Python. You just need to understand Python basics and how to interpret Python codes and all those stuff. So it's not like someone going into incident response. You don't need to learn any programming language. So it depends on the field you're going into. So that's for the person asking if there's any specific programming language for cybersecurity. So there's no specific programming language for it. It depends on the area you're going into. Okay. So sorry. So another person said, sorry, sir, what do a normal ethical hacker face? Okay, sorry, sir, what do a normal ethical hackers face problem that can they recover lost accounts? Secondly, what tools do they use? So, okay, about recovering lost accounts is more of your skill. It's more of your skill. It's not really more of your skill. It's just as an ethical hacker, or as a cybersecurity specialist, you have this problem solving skill in you automatically because you solve a lot of problems, you face a lot of problems. Because in this field, you face a lot of problems. I will not lie to you, it's not something very smooth. You have to be prepared mentally. So you face a lot of problems. So you've solved a lot of problems. So when you face problem like recovering lost accounts, it's just more of problem solving that you use. You just use your brain and problem solving to recover the account. So it's not like there's a specific course on cybersecurity on how to recover accounts or there's a specific tool. So there's nothing like that. It's just that as a cybersecurity specialist, you have these problem solving skills that you just feel you should protect everybody. So if there's anything wrong, you just have the urge of protecting the person, recovering the accounts and things like that. So it's not like there's a specific course or a specific tool for doing such. So I don't know if I answered your question, Joshua, or if I don't answer your question, you can resend the question. So Sunday, what is the main OS? What is the main operating system for cybersecurity? Okay. So there is no main operating system, but the most used operating system is Kali Linux. It's Linux, but we make use of Kali Linux in general. So I'll type it out. So we have Kali Linux. So we also make use of Windows operating system. We make use of Mac, but the most used is Linux, as Kali Linux. That's for Sunday. What is the main operating system for cybersecurity? So it's Kali Linux. So if there's anyone that have more questions, you can just raise up your hand or you type it out or something. Anyone? Okay. If there is no one, if you still have more questions, you can drop it on the group chat. I will attend to that. So I think I'll hand over to you, boss. Walter.
Okay. Thank you so much, Emmanuel, for that session of enlightenment. I believe we've all learned a thing or two, and we've all gotten more insight. Exactly. if this evening has been impactful. Exactly. Thank you. Thank you. Thank you. So this is 9:14. So I'll just leave the next 1 minute for any questions. So if you still have questions, raise up your hand or you drop it in the comment section. So we'll have just 1 more minute for questions, and we have our closing remark and wrap up so we can go and rest and prepare for the class tomorrow. Any questions? Any questions? Any questions? 30 seconds to 30 more seconds to 13 questions or any concerns. If there's anything you want to know, maybe about the program in general or about the course. Okay. If we are good to go, can I get a thumbs up? I know that we're good to go. Can I get a thumbs up? So I know that we are the same page. Can I get a thumbs up so I know that we're on the same page and move on? And Friday again, the classes will hold. So on site, which will hold in our hub tomorrow, will be by 11, while the online will be by 8 p.m. So for those of us who will be taking our classes online, our classes will hold by 8 p.m. While for those of us who will be coming to the hub, it will be by 11 a.m. in the morning. So make sure you're there before 11 so you can be properly seated and relaxed before the classes starts. And as you're coming, come prepared. You're coming for a tech training, not what is that name? Forever living product training. So ensure to come with your system, come with your writing materials, come with your heart, come with your mind. And I want to believe God that before the end of your training, you must have seen a different you. And if you've not made payment, please, 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 please make sure you use the link, or if you don't have the account, just write me and I will send you the account details. Make sure you make your payment tonight, because your payment, it's a validation for the classes. So if you've not made any payment, that means you've not been onboarded. That means you're not yet part of us. So make sure you make your payment. And if you feel this is an exciting opportunity, do well to tell people around you, your friends, your neighbors, your lovers, anybody you feel will need this. Also tell the person about what's going on and let the person get involved what they're doing. And like we said, this week and next week will be a general class. So this will be a general class. So everybody will be learning the basics together. So to be a time to bond. Then by the next 2 weeks, we'll separate into our different classes. So just make sure you're on time and make sure you do the right thing financially so you can get the full package without any hindrances. I don't know if Ms. Precious is available to say something before I call it a wrap. Precious, are you free now? All right. I guess she's still busy, but that will be it for tonight. See you tomorrow at the hall by 11 a.m. Tomorrow by 11 a.m. for the online class. Then 8 p.m. Sorry, for the on-site class, 11 a.m. Online, 8 p.m. And thank you and have a good night.